So what? Yeah, resource is valuable, yes.
So you cannot increase something variable for nothing.
Okay, so we kind of established that, right? But what about decreasing it? Okay, so yeah, I mean, you found an easy way out saying, okay, so you cannot actually keep increasing something for nothing, right? What about just keep decreasing it? So what if you have a resource and the only economic events that you have in your model, just keep decreasing it? And there are no economic events that are increasing.
You can't do that, but you go backwards.
Yeah, you're right. Yeah, basically what happens if you keep doing this? You will completely deplete your stock of that resource, right? It will go to zero. And if that resource is essential to your business model, then you cannot keep operating anymore, right? So if you are only increasing it, it goes to infinity. If you keep only decreasing it, it goes to zero. So those things cannot happen. So what has to happen is that there has to be two events, right? That both increase and decrease the same resource. Okay? So this is what, and when you think about it, so it will force you to extend your cycles beyond this. So because in this you look at this, for example, say cash, right? So even if you combine purchasing with payables, right? So what you will see that your cash is only decremented because you keep paying your vendors, right? Obviously there have to be events that increment your cash, right? And for example, such events will be modeled in your collections cycle, right? So when you collect money from your customers. So, but it's going to be the same cash. So you see that the resource entities become the integration points in your global conceptual schema. So where all those different business cycles actually have to interact, and it is essential to have an integrated model that will allow you to maintain a real-time system where you see what is going on all the time. Okay? So when we talked about generalization decisions that have to be made, right? So what has to be actually made more specific, what has to be combined and be extended beyond this cycle, right? So I said that so you have to add cash receipts, right? Inflows for cash. And the same would happen with inventory. You cannot just keep buying inventory, right? You also should start hopefully selling that inventory to your customers, right? So all that has to be added. Okay, so we are done with the basic RA model, right? And now we come to a stage where actually it's very interesting that the paper talks about this very important concept called conclusion materialization. So what is this? Well, basically, if you consider this ideal situation, don't think about any constraints that, say, physical considerations will impose on your system. The constraints of storage, the constraints of processing, just ignore them for a second, right? So they're not there. So pretend that you are infinitely capable, infinitely powerful, right? You can store as much as you want data. You can run whatever calculations you want. No problem, okay? So what would be your ideal information system where all the details are preserved, nothing is omitted, no aggregation ahead of time, so capturing the raw data in the most disaggregated form at the source. So what will your ideal system do? Well, such an ideal system will simply keep capturing the records of what has been going on. Okay? Just completely recording all the events in all their details. And that's it. Why? Well, because later on, when you want to figure out, okay, where do I stand now, or what, for example, what has happened during the last year, you simply select from that system what you want, do all the number crunching necessary, and arrive at the results. Okay? So in the ideal case, the only thing that is needed is this complete record at the source and nothing else. So then if you start from day one, from the creation of the universe, you record absolutely everything. So you add things, subtract things, so you know how much you have on hand, you know how much people owe you, you know what you sold last year, you know everything. You just add, subtract, and get the results. Now you realize that our assumption is impossible, right? So that we always have those physical constraints. So you cannot keep this record from the creation of the universe forever in that raw form. So we have to make certain accommodations for this. Okay? And these accommodations will actually deviate from the basic principles of database design, where it say, you know, we keep all information only at once, we don't keep any data that can be calculated, we do everything on the fly. Okay? So we'll have to deviate from that. And the process of doing this is what is called in the article conclusion materialization. So this is some kind of intermediate calculations, calculating these snapshots. So we have these records of continuing activities, but then we have to actually add up things and to know what is going on. So what are we going to do? So we will materialize conclusions about resources and claims. Okay? So conclusions that we materialize will be derived from imbalances. So as far as resources are concerned, those will be imbalances between increment and decrement events affecting those resources. Okay? So I'm saying this in this fairly abstract way, just to be more specific, to make it easier for you to comprehend, because you know, when you're talking in this completely abstract way, it is difficult. So, for example, let's say that we're talking about, say, merchandising business, and we're talking, for example, about a resource which is inventory of goods for sale, right? So what are the imbalances? So the imbalances are between what we put in, so we get something from the vendors, right, which increases our inventory, and the decrements, which are shipments to our customers. So this is what we sell. So the difference between what we bought and what we sold is what we have on hand. So one type of conclusion materialization will be this calculation of quantity on hand of a particular resource, in this case, say, merchandising inventory. Okay? Now, again, in the ideal situation, there is no reason to keep it in the database, because you can always add and subtract and calculate what it is, right? But if we have a large volume business with a lot of increment and decrement events, and we want to know all the time what is the quantity available on hand, no system will ever be able to maintain this ongoing cycle of recalculating the same thing over and over again, right? So therefore, we actually store that. So we do store some of those conclusion materializations in our database, even though, strictly speaking, in the database terms, they're known as the so-called derived fields. Okay? Fields whose values can be derived from the values of other fields in the other records in the database. And one of the fundamental database design principles tells us that we really should avoid derived fields. But this is in theory, and in practice, actually, it's impossible to avoid. So another type of conclusion materialization involves claims. And claims derive from imbalances in the duality relationships. Okay? For example, accountants are obviously interested in knowing the current value of accounts receivable, right? So you know that accounts receivable are very important, right? It's an important current asset, and you want to make sure that it is realizable. You should be able to collect on that and all that stuff, right? So, but what is accounts receivable? So accounts receivable is your claim to your customer, right? Which results from the imbalance between the value of the delivered goods and the amount of the collected cash, right? This is exactly what it is. So your goods were worth so much that you gave to the customer, right? Those are decrement relationships that you have, right? So you decreased your merchandise inventory by that much. And the dual relationship was cash collections, right, from the customer. So you increased your cash resource by that much. And the difference is this residual claim. So when you add all those residual claims up, the total will be your accounts receivable. Again, exactly the same story. Do we have to store it? Well, in theory, the answer is no. So if we have the records of all those events, right, we can add up the value of all the goods delivered, right? We also can add up the amount of all the cash collected from that customer, right? And when we subtract the latter from the former, we will know what this residual claim is, right? That's in theory. In practice, we know that we do materialize conclusion about this. And if you look at any system that maintains records about their customers, I'm ready to bet my life that pretty much every system like that will have an attribute in that table which says current balance, right? So for every customer's account, you will see an attribute which gives you the value of the current balance of that customer, okay? Are you with me or you're not? So this is exactly this example of conclusion materialization, okay? So we materialize conclusions about both resources and about claims. Okay? By the way, again, so the article is very careful. You see, I was giving you an example where the imbalance is positive. So where we have accounts receivable, which is an asset. But you know that depending on how you run your business, you may have a situation where this imbalance is actually negative, right? Or in the accounting terms, you don't have an asset. You have a liability called prepaid revenue, right? So which happens when? So I gave you an example when we have this, when we materialize conclusion about this, but you also can have this.
You get the cash, but you don't deliver the goods.
Yes, so you make your customers prepaid, right? So they pay you in advance, before you ship the goods. Okay, so then you will have a liability, you will have this prepaid revenue you have already collected in advance, but you have not shipped the goods yet, right? Okay, so this imbalance can go either way, depending on your business process, right? But it doesn't change the fact that these are very important numbers, and we need them very, very frequently, and we have too many event records to keep recalculating those numbers over and over and over again. Okay, so therefore we do this. Okay, so we do have derived fields in the REA database, even though this high theory tells us that we shouldn't. Okay. So, by the way, I mean, so in conventional accounting terms, what my discussion really implied is that, you know, that such a standard artifact as accounts receivable subsidiary ledger, okay, in fact, is nothing more than a report that you can run against your enterprise database. Okay, so this is nothing but a report. And it means that we actually don't really have to store it in principle to materialize conclusions. But again, as we just discussed, the fact of the matter is that yes, we do, because otherwise it would make our systems impractical. So I can tell you that if you try to do that, I can tell you what would have happened. You would have simply paralyzed your transaction processing system. So again, in theory, we can run the so-called ad hoc queries. So we have this relational database. Whatever query comes to our mind, we can write a SQL statement, throw it at the database. The database will start crunching the numbers to calculate the result set for our SQL statement. Now, in practice, that our query can be so complex and require so much calculation that the database will grind to a standstill, and the response time will just go through the roof. And people see, okay, I'm trying to record the sales transaction, and the damn thing is not moving. Why isn't it moving? Well, because you allowed such a monstrous query to be executed. So again, you have to be reasonable. So according to this ideal situation, yes, I mean, they can handle ad hoc query, not like the old type databases. In practice, you have to be reasonable because it may not be always possible. Okay, any questions about this? So, but this is a very important topic, this conclusion materialization. So how do we actually materialize conclusions? There are a number of different ways of doing this. And it really depends on our requirements for maintaining a consistent state in our enterprise database. Okay? Now, some of those conclusion materializations can be just for information purposes, and they can have no effect on the maintenance of the consistency state. Some do, and it really depends on what we do. Now, first of all, we distinguish between those things that we do instantly and we do periodically. So what's the difference? Well, it really depends on what you're doing, but basically this instant effect is when something happens. For example, you sell an inventory item, okay? It is captured by the system somewhere, right? Do you update your inventory level at the same time? Right? Do you update your inventory level at the same time? Well, these days it seems to you that the answer is no-brainer, right? So of course you do. Why not? Well, in the old days, the answer was that because it was very expensive and laborious and time-consuming. So therefore, the so-called real-time inventory systems were not commonplace. In some places, for a long time, practiced what is known as inventory counts. Okay? So even some fairly large entities, in some cases, did that. So what do you do? What do I mean when I say inventory counts? Well, it means that you keep selling stuff, but your inventory is not updated. And then periodically, it may be, say, once a month, it may be once a week, it may be at the end of the working day. I'm not talking about the frequency. The frequency is whatever that frequency is, but it is periodic. You do the inventory count, and you adjust inventory value accordingly. Okay? So it was very common procedure, those periodic inventory counts. So this is what you see here. So it does have effect on the consistency. Until you updated your database is an inconsistent state. Because you may have already recorded the sale, but your inventory level is not updated. So what if you want to have it in real time? Well, at the time when this article was written, so Bill wrote that, well, basically the mechanism for that is the so-called triggered procedures. Well, all databases allowed triggered procedures. So what is a trigger? Some people call it just a trigger. It is basically a piece of code, like a subroutine, which is stored in the database. And whenever a certain event happens, right, the procedure is executed. So for a while, people actually were thinking, they were used extensively. So I don't know, Miklas, somebody is going to talk about continuous auditing here, right? You are going to talk. So I don't know if Miklas is playing, but one of the early continuous auditing papers by Grumer and Murthy talked about the architecture where continuous auditing was also implemented as a triggered procedure, which was written in the late 1980s. What people realized about a decade later was that, you have to be very careful at what level your triggered procedures are implemented. And it turns out that it would again kill the performance. Basically, you cannot put triggers on the transactional tables. So if you put triggers on the transactional tables, you will freeze the database. Again, I don't know if anybody, maybe you already have heard about enterprise resource planning systems and about the 3-tier architecture of the enterprise resource planning systems. That there is this database level at the bottom, there is this middle tier, the application tier in the middle, and there is this presentation level or presentation tier at the top. This is what the users interact with. So this is the modern architecture, more or less. So it turns out that the triggers, that the proper place for the triggers is actually at the middle tier. So it is at the application layer, which is typically going to be on a different computer. It's not going to be on the same level where the database engine is. And the reason for that is that when you are talking about a real-time system with a very large number of users, you have to design your processing in such a way that you shield the database engine as much as possible. Otherwise, it will not be able to support a very large number of simultaneous users. So this is what I had to say about those procedures that have effect on the maintenance of consistency in the database. Then you have something which is known as views and derivations. So when you need to know something often, so databases allow you to have the so-called views. You can think of a view basically as a stored query. So what is a view in a relational database? It is basically a stored query. So you have a certain query, but you don't keep it outside a database. So you keep it inside. You can give it a name. And it will look to you as a table, basically. But it is not a physical table. It is a virtual table. And it is calculated on the fly. Whenever you use it, basically the result set of that query that you stored is calculated. And the table is ready for your presentation. So it changes dynamically. It is very convenient. In many cases, it is used for security purposes. So from that point of view, it is instantaneous. So whenever you need it, it is there. But it is not really a physical table. Okay? So you also can have just an external procedure that simply does this derivation for you. So in this case, it is not a part of the database. You don't really use it in the same way as a table, but whenever you do it, you just use it as an external procedure. Okay, so these are the procedure types that you can use for conclusion materialization. Okay, so there are additional things that you may want to do. And again, they deviate from the basic model. And this is what the article is talking about. So they say that you can treat claims as base objects. So what, okay, and by the way, we'll just continue with that. So let me go. Then you can do this summation of economic event data over time. So you can do this partition combination of economic events. You can treat duality relationships at the macro level. And there are also equity transactions that I don't think I will go over in detail. Okay, so treat claims as the base object. So what does it mean? Well, I gave you an example of accounts receivable, right? And I told you that this is basically a report, right? But people who work with the traditional accounting systems, they say, well, what are you talking about? Accounts receivable is a subsidiary ledger, is a standard artifact. I want to have it in my system explicitly. Okay? So what does it mean? Well, it means that for this model, you would have to create a new entity for the claim. And this is not a type of the entity that we talked about in the REA pattern, right? So you can ask me, so why not? So what is the difference? Because you see, if you go back to our discussion, so let's play along. Let's keep talking about the sentence. So we're talking about accounts receivable. So we talked about resources, events, and agents, right? And if I think about the definition of the resource, right, that we talked about, doesn't it resemble what the accountants call an asset? Right? And again, if you think about it in your mind, intuitively, when you talk about resources and when accountants talk about assets, don't you really identify the two? So what's the difference between a resource and an asset? Well, the essential difference is that accounting assets also include claims, right? So everything that we call the resource, whether we talked about inventory or cash or whatever, right? Absolutely everything was an asset. But those residual claims were not. So accountants treat them more or less the same way. Shouldn't we treat them the same way? Well, and a short answer is, well, generally speaking, not really. Because those claims are derived. Okay? What we call resources are actual physical things, right? And we are talking about event-driven systems where we record information about economic events, right? So if you add entities that represent those residual claims, right? So basically, if you add those things to represent your assets and liabilities. Then, in effect, you will transform this into a replica to a certain extent of a double entry system. Okay? So the system as is designed as an event-driven enterprise system is a single entry system. Right? You ship the goods to your customer. So you made a record about the shipment. Right? You don't add a separate record that you now have accounts receivable. Right? If you do this, you can do this. You will have to. Okay? So you will have to add those events that will be incrementing and decrementing those claims. Right? So you collect cash from your customers. Right? You increment cash. Right? You will have to decrement accounts receivable if you keep it as a separate entity here, if you make it a base object. So this decrement of accounts receivable is double entry bookkeeping. Are you with me here? Now tell me, is this too high level of an abstraction? Can you talk at this, or I really have to give more examples? Because you look depressed. Most of you look depressed. Don't they? They do. Okay. So as the points here says, so at times people do this. And they do this for computational reasons, because in some cases we cannot afford to recalculate. And we need certain information all the time. So we cannot keep recalculating it all the time. But basically it is a deviation from our modeling principles. So we do not need double entry bookkeeping anymore. Double entry bookkeeping information is derivable from what we have. We can add it here, but it is not needed. When we add it, we'd better make sure that we put controls in place so that people don't screw up. So basically we are back to checking the debits equal credits when we do this. Okay? But it's not needed. It is a single entry system. Okay, temporal summation of event data. How much do we keep? Well, you know, Miklas told you that in the mid-1980s they kept 3 months of call detail data in the database. Now here, even the most powerful enterprises don't keep all the records. So we have different categories of storage. And what we call online storage, this is where all the operations are, will be limited. Whether it is limited to 1 year of data or 3 years of data, you can be assured that it doesn't contain, say, 30 years of data. Okay? So it is limited. So there are certain things where we just add things up, and we have, and then what do we do? Well, we have what accountants call beginning balances, right? So we added, what is a beginning balance? This is the aggregation of everything, all those events that have happened up to that point. Right? So, and yeah, we're gonna be doing this to a certain extent. But this is still done, even with all the modern systems. You know, if you go current technology, that there is something called network attached storage. Those are very high powered systems, basically, that there are these whole storage farms with huge amounts of disk with redundancy, which are available online. Still, we cannot keep everything forever. again, it is business driven. If you are a life insurance company, okay, it is quite possible that you keep 30 years of records in your active storage on live. Why? Because this is what your business is all about, right? Because this is what you're doing all your calculations with now. But if you are a retailer, I guarantee that you don't keep online even 5 years of storage of all those records. It would be interesting. I don't know, say, how many years Walmart keeps. Would be interesting to find out. Okay, I already alluded to this before. So advertising service acquisition, advertising service consumption. So do we split those events or do we treat them separately? In many cases, particularly as, say, when accountants say, then we expense something right away, right? And you know that there are certain things. So, for example, advertising has to be expensed, right? Research and development has to be expensed, that kind of stuff. So the system would follow those conventions, and this will not be, so we're not going to be modeling this. So what is shown here in the dotted line will be omitted, even though it does represent the reality. That you know that we actually get this advertising service for something, right? Which will be used then to generate sales or whatever. But we can just ignore these details and just expense it. Or another example, which may be even easier to understand, that I often give when I talk about this. Think about paying your utility bills, right? So in a modern society, you cannot do anything without electricity, right? So you get a bill from your electric company, right? And you have to pay that bill. So you have this economic event, right? Paying my electric bill, right? It decrements your cash, right? So REA tells you that there must be duality somewhere, right? So if you decremented cash, right? So there has to be a dual event that incremented something. So you just paid PSE&G your electric bill. So you decremented cash. Where is duality? Where is it? So where is duality? There has to be a dual event. So what are you going to model? So you have to pay, right? So we cannot run without electricity. So where is the dual event? So what would be the dual event?
Get electricity.
Good. So the dual event, so when I paid the electric bill, I gave cash. The dual event, I have to get something, right? So what do I get? I get electricity, right? So it means that in my model, I have to have another base object, another resource called electricity, right? And the dual event would be receiving electricity. So PSE&G gave you a certain amount of electricity. So certain number, say, of kilowatt hours, whatever measure you use for electricity, right? So you have to have this resource called electricity. And you are receiving electricity from PSE&G, right? So this is what the dual event is, right? Okay, so but let's continue with the REA also tells you. So now you have this resource called electricity. And you have the event receiving electricity that increments it, right? You remember we talked about the fact that for every resource, you have to have events incrementing it and decrementing it. So you cannot just keep incrementing your resource of electricity. So there should be events decrementing it. So what are they?
Manufacturing.
What?
Manufacturing.
Manufacturing. What about office work?
Oh,
What about corporate accounting function? What about absolutely everything? So basically, all those decrement events. Again, if you follow this through, and you create those entities to model them. So what are you going to be doing? You are going to be implementing this extremely detailed cost allocation scheme. Because those events, you say, okay, I consumed so much electricity for assembling the product, and so much electricity for just doing office work, and so much electricity for meeting with my clients, right? And so much electricity for preparing my advertising material. And all those would be different events that would be decrementing electricity. Is it worth doing? Is it really worth doing? So you put the meters on every office door, and then periodically you record, okay, this office work actually consumed so much electricity. Well, I mean, in most situations, the answer is no. So you're going to collapse those things. You're going to forget about them and not do it. Of course, if you are actually producing aluminum, oh yes, then you're going to be keeping track of electricity. Because I don't know if you know, but aluminum production requires incredible amounts of electricity. So this is one of the primary inputs. So when you're producing aluminum. So there are certain manufacturing processes where that is critical. And then you really have to know that really makes or breaks your business. Right? So then you would do it. So whether you go through this whole thing or just combine it really depends on the particular situation, right? So this is not a detailed prescription. This is a general guidance, right? How to go about modeling your systems. Matching is a macro level duality. So in a way, this is what we were talking about, right? So it's not just electricity. So we are, say, spending money on ads, right? We also have, as what accountants call, fixed assets, right? So we have our buildings, we have this industrial equipment, right? And we keep using it. So in accounting terms, we are recording depreciation, right? Well, we all know that this accounting depreciation doesn't really have much in common with the true economic depreciation, right? But because it is so difficult to measure economic depreciation, we are getting by with just the accounting depreciation, right? But the thing is that it is really happening on the event by event basis, right? So every sale or every manufacturing process really consumes a little bit of that and a little bit of that. So if we followed again on the guidance of the REA, we would capture those consumptions at those micro levels, at the level of individual records. Is it worth it? Well, probably not, because we cannot measure it. So in this case, the answer is definitely no, because we don't really have a good way of even measuring it. So how much that advertisement contributed to that particular sale? Well, you know, actually, in some cases, they ask people, okay, how did you hear about us? Or whether you actually saw our ad on TV. So in some cases, they make an effort to keep track of that at the micro level, at the level of individual records, right? But in the global scheme of things, this is too much, right? So they don't keep track of that at that level, okay? So for that reason, what they do, there is okay, so again, this is a simplification and deviation, but we are going to do it only at the macro level. So therefore we go with those estimates, and this is what our system will do. By the way, it will require additional things in the system. I don't know if you have noticed, but I didn't mention anything like the general journal and the general ledger so far, right? Because in a way, those things again would be like reports. They don't. General ledger is definitely a report, and general journal is something which we can do in the calculations. But the truth of the matter is that yes, we still need them, and again, as a deviation from this ideal situation, we will still have them, and we'll, because we need to do certain things at this level, because that's the only level at which it makes sense. Doesn't make any sense to go to the micro level here. Any question? So it is very interesting what Bill put into this. So he said that, look, I mean, we really have to extend it beyond what we were talking about. And the next article will address some of those issues. As far as implementations are concerned, I didn't mention those words before, declarative and procedural. But those are very important words. Basically, things that we talked about, most of them today, are really about declarations. And the idea of relational databases in general was to get away from embedding business rules into the code of the programs. It is a very bad idea when the code itself implements certain things that you do in your business. The code has to be neutral. And what you have in your business has to be explicitly stated somewhere. Okay? And this is what we're trying to do in relational databases. Even the language that is used to manipulate, to create relational databases and manipulate data in relational databases is a so-called declarative language. It is called SQL, Structured Query Language. Traditional programming languages like Fortran, COBOL, C, C++, Java, C#, whatever. All those languages are procedural languages. So what people do when they program in those languages, they describe step by step the procedures that the computer has to execute. Okay? A structured query language is different. It is a declarative language in the sense that it doesn't describe any procedures for the computer to execute. It simply specifies the result that we need from that computer. And it is up to that computer how to generate that result. So for you, it would be important to remember that whenever we could, in all our endeavors, we should try to stay away from putting what we need into procedural things. And we should try to make it as declarative as possible. Because declarations are explicit. And when you put something into procedure, it is in that procedure implicitly. It is very difficult to get out of it. And if you probably have never had any experience with that. I spent a fair amount of my time in my life actually programming computers. The most difficult task that you have when you program a computer is not writing your own code. That part is actually fairly easy. The most difficult part is to read somebody else's code and understand what that code does. Or to read your own code that you wrote 2 years ago and understand what that code does. Okay? So therefore, that procedural things are very tricky. Whenever you put something into those procedural things, it's very difficult to work with. It is so implicit that it is just unworkable. So we do want those declarative means. Now, in our abstract models, we wanted to make them as parsimonious as possible. Now, when we start thinking about controlling the systems and making sure that things don't break down, we realize that there is a certain need for redundancy. And again, that would mean, okay, deviating from certain basic principles and not making the system as parsimonious as we would normally want. And finally, as I said, so satisfying traditional general ledger needs, and I said that there are accommodations. Yes, every modern enterprise system does have a table for the general ledger accounts. We claim that they're just reports and we can calculate them, but the table is still there. We do conclusion materializations in those systems. Integration with non-accounting systems. This distinction is a kind of obsolete these days because large companies don't really have standalone accounting systems anymore. So accounting systems are integrated completely now with other enterprise systems. So it is the reality. And internal control specifications and audit evidence gathering. Well, here audit evidence gathering is still probably somewhat in the future, but internal control specifications, so we'll talk about policies. So I'll move to the next paper, and this is where we're going to talk about this. Now keep in mind that this paper was written 25 years later. So when you compare the two, so it's a very, very long period of time, right? So and this is a very interesting paper. And it provides, again, this declarative ways, declarative means for specifying enterprise policies. Okay? And as the previous discussion indicated, this is really important to be able just to declare them, not to put them in the code. So what you see on the bottom half of this slide is what we just discussed in the first paper. And what is called in the second paper, the operational level. Observations feed into the system generates the facts. So this is the operational level. They call it also accountability infrastructure. What actually happens, okay? And here you see this, as we call it now, classical REA pattern. So this is the kind of entities that we use at this operational level: resources, events, and agents. Okay? So, and what you see at the top is the so-called policy level. So the operational level at the bottom, the policy level at the top, right? And this is where we try to describe our corporate policies, and our planning and control goes there. So these things that are specified at the top define what should be, or could be, or must be, okay? And the kind of entities you see at the top are different. So what is used in the paper is the type of entities that are called typifications and groupings. Okay, T and G, typifications and groupings. And you will see that those policies are expressed through a number of different means. The so-called knowledge intensive descriptions, validation rules, and target descriptions. Some of those things will function basically as preventive controls. So things like knowledge-intensive descriptions and validation rules, when they're integrated with what is actually happening in the system that records it, they will actually enforce certain things. Certain other things, like target descriptions, can be used as detective controls. So they're not going to be enforced, but after the fact, you can determine, for example, whether you stayed on budget or you didn't stay on budget, right? Or whether, say, your fuel consumption was within acceptable limits or was outside acceptable limits, right? Things like that. So you will see that in a second. And what is important here that you see that the two things are integrated, which allows us to implement those controls. Okay. So what are the types of policy definitions? As I said, knowledge-intensive descriptions, validation rules, and target descriptions. So knowledge-intensive descriptions, they give us certain characteristics that have to apply to any object that we describe at the operational level. So, for example, you are selling many different bottles of perfume, right? At the policy level, you will have a description that tells you that actually this very old, by the way, very famous perfume Chanel No. 5 costs $75 a bottle. Okay? And depending on how your system is implemented, so you can make sure that this is actually enforced. You don't really even have to have it at the operational level, it is at the policy level. Or you can put upper and lower bounds on the salaries of your employees, right? So both are important. So the lower bound is there to comply with the minimum wage laws, right? And the upper bound is there to make sure that a payroll mistake is not going to ruin you, right? If for whatever reason you cut a check to your employee for $50 million, that's probably the last time you're going to see that employee, right? And you may never be able to recover the money. So you would have a validation rule that tells you what the bounds are, right? And then when you have the payroll runs at the operational level, the validation rule will be enforced. So that's a preventative control. Okay. And target description, they provide the benchmarks. And those benchmarks may not necessarily be mandatory, right? So it can be standards or budgets. As I say, okay, are you making your sale goals, right? Or are you energy efficient? Things like that. Okay, so what is typification? So I said that we're going to talk about two primary means. So in those two abstractions, two semantic abstractions that are used in this paper are typifications and groupings. So a typification is a way of capturing certain commonalities of a set of objects. Okay? So I have a number of different planes on the ground, right? But all those planes happen to be Boeing 737. Okay? So therefore, I can have this entity describing this type of a plane, Boeing 737. If for no other reason, then it would be enough to specify for each of those actual planes that they're just Boeing 737, and they wouldn't have to describe any of those common features of those planes, right? So it makes perfect sense. By the way, there is this example where they do exactly this, and at the time when the paper was written, Boeing 787 didn't really exist yet. So therefore they said that this is an example of a typification for which no actual object exists. Okay, now as you know, we do have those guys, right? Some of them were even grounded for different reasons, for problems with the batteries and other things. But this is what happens. So this is an example. So at the operational level, we will have the entity of actual planes, right? And those are, those P1, P2, P3, P4 are actual planes. Think of it like certain planes that have, I don't know, an identifier, like a serial number or whatever, okay? And what we have at the policy level is this plane type, which describes the common features of different plane types, right? So this is a typical typification abstraction. By the way, this is a very modern paper, and you may have noticed a difference in notation. So the original, the first paper that I mentioned, used this standard entity relationship notation as proposed by Peter Chen, right, in the 70s. This paper, basically what you see here, the way it is presented, these things are known as the UML class diagrams, okay? UML is known as, UML stands for the Unified Modeling Language, okay? And this is a very flexible and very powerful modeling tool, okay? So this is a small subset of that language. So in a way, UML class diagrams are more or less functionally equivalent to extended entity relationship diagrams. Because what you see here, you see not only entities and their relationships, but you see these multiplicity definitions, which basically describe the optionality and the cardinality of those relationships in the terminology of extended entity relationship diagrams, right? So basically, so this is a relationship of a kind of, and you see that the multiplicity here is 0 to infinity, 0 to many. So it means that for every type that we describe, it's possible that there is no actual representation. So that's why we have 0 here. But it is also possible that there are as many representations as they manage to make, right? Whatever. But in the other direction, that if you take a plane, a particular plane, that plane will be of only one type listed here. So this is this multiplicity of 1 means, right? So in this old terminology of the extended entity-relationship diagrams, so this means that the participation of this entity is mandatory 1. And the participation of this entity is optional many. For those of you who are familiar with the terminology. Okay? But otherwise it's more or less the same thing, so that you understand what is written there. Okay, so this is a very interesting discussion about a difference between typification and generalization. Okay? So when we are dealing with types, the instances of the types, so subtypes as we call them, right? They actually correspond to certain general subsets of these objects, right? So here we have this base object called employees, right? And these are actual employees here, right? So this entity will actually have information about these actual employees, but these employees are of those types. right? So it means that employee is actually a generalization of these particular types of employees, right? So the relationship between the entity of employees and the entity of employee types is a relationship between the operational level and the policy level, right? Then the question arises, do we really need to model a generalization relationship which is gonna be at the operational level? So do we actually need those special type of entities that represent salespeople, buyers, and cashiers? Or we don't? Because this is the employee is the general entity, and these are special type of entities. Do we need special types of entities? And as I alluded to before, the answer is it depends. We need this generalization relationship if something of business importance distinguishes them from everybody else. So like you see that, like the example here. So a buyer is a special type of an employee, right? And we know that it's modeled there. And here there would be all the descriptions common to all buyers. So the records in basically in that table will just describe the attributes common to all buyers, right? Here at the level of the employee, there would be the attributes that describe common things that all employees have, right? So whether we need a separate entity for this depends if there is anything of business significance, right? That requires that. And they say yes, in this case, yes, look at this. Buyers actually, because of their job functions, they are given a credit limit, right? So they cannot buy more stuff for the enterprise than their available credit limit. And you know that these days often it is implemented through corporate credit cards. I believe American Express started that. That you know, they say that you know all those transactions should go through the credit card, and for each of those buyers there will be a credit card with a certain limit. And you can keep getting stuff until you reach your limit. And then, now where do you keep track of your limit? Well, you keep track of this separate table. So basically, this is an example for a generalization relationship, right? So you have a general entity, employees, and you have a more specific sub-entity called buyers. And by the way, you know, again, I'm not really going into the nitty-gritty of that. But if you look at the database implementation, so a generalization relationship, why do computer scientists talk about it? So what makes, say, a generalization relationship is somewhat special is that when you implement it, you know, if you remember anything about relational databases, so relationships are implemented by means of common attributes, by introducing foreign keys, right? In the generalization relationship, it is the primary key that becomes the foreign key. So basically, there will be a table of employees with the primary key employee number, and whatever attributes that are common for all the employees. Name, date of birth, date hired, social security number, hourly wage, whatever. Okay? So those are common employees. So what you're going to have here, you're going to have the same primary key, which is going to be the employee number. You can do it. Why? If it was unique for all the employees, it will still be unique for the subset of employees, right? And you will have a special attribute called credit limit. Okay? And nothing else. And the employee ID is not only the primary key, but it is also the foreign key linking back to the employee table. So when you join two tables on the employee ID, you will be able to know all the standard employee attributes for that employee and the credit limit. Okay? So similarly, say you have salespeople. Do you need this generalization relationship? You do if there is something of business significance that you have to keep track of. For example, as we talked before, commission percentage, right? So same thing, salespeople table, employee ID, both the primary key and the foreign key and the commission percentage, okay? And though at the top we will have just the common attributes, okay, for those types. Questions about this? So let's talk about grouping. If typification represented a kind of, grouping represents a member of, okay? So the records in the entities that are groupings will give the common features of those aggregates. Okay? So things that are grouped together are not necessarily of the same type. You see, that's the difference. It doesn't have to be. So it's very different from typification. Now, another interesting feature about groupings is that very often what is important for us, that when we describe groupings, we really want to know values of certain derived attributes. So those conclusion materializations that actually can be calculated. Very often we need them all the time. They don't change that often. Okay? So therefore it doesn't make sense to keep recalculating them over and over and over again. Okay? So therefore it is quite common to see a lot of derived attributes in the entities representing groupings. Okay? So here is an example. Planes are grouped into fleets. Okay? Planes are grouped into fleets. So you can have a fleet of Northwest Airlines, and you can have a fleet, but it doesn't exist anymore, by the way. You know that we had a major consolidation of airlines. We have a fleet of American Airlines, we have a fleet of Delta, right, United, so on. And by the way, what is grouped together are typically planes of different types. You remember, right? Why? Because those fleets typically have different kinds of flights that they serve, right? Shorter distances, longer distances, with a lot of passengers, with fewer number of passengers. So they do need planes of different types. So typifications are very, very different from groupings. Again, this is a relationship between an operational level and the policy level. And same thing here, by the way. Here the assumption, you see again, so a fleet can have no planes, you just created an airline, right? You don't have any planes yet. Or as many planes as you wish. But a particular plane can belong to only one fleet. So this is the property of the relationship that you see here. Now, again, in this UML notation, when you see this forward slash in front of the attribute name, that represents a derived attribute. So things like the number of planes in a fleet, or the average age of the planes in a fleet, are actually derived attributes. You can calculate them by aggregating the information in the related records in the plane table, right? But since those don't change often and we want typically to know them all the time, it is very typical to keep derived attributes in the grouping tables. Again, a deviation from the basic database design principle, right? In basic database design principles, we don't want to see derived attributes, right? But when the alternative is worse, we say, okay, there is a difference between theory and practice. Okay, so so as I said, this is a kind of versus a member of type of relationship. Now, typifications are really things which are permanent. Groupings define what is actually happening typically now. Now, there is also this power type. So, if you are a member of a subtype, then you're going to be a member of the general type. So this is actually transitive. This is a non-transitive. And in groupings, so the instances of groupings are not subtypes of the member class. So planes are members of a fleet, right? Smaller fleets are not members of a fleet. Okay? So this is basically what it says. So these are very different types of abstractions. And this is a hybrid representation because we can group by type. So this is what is very interesting. So you see, so we have, on the one hand, we have typifications, on the other hand, we have groupings, right? But we can also group by type because we can group based on whatever we want. And in particular, we can group by type. So if we group by type, then what we end up with is a hybrid representation. Okay? So in this case, for example, where would we do that? Say, when you have people who are managing certain types of products. Okay? So you are in charge of all your current 737 planes. So on the one hand, 737 is a type of the plane, right? So therefore, at this level, we have those like perennial characteristics of 737. So the number of engines or how far it can fly. So those are just basically permanent features. They are properties of the type, right? And then we have the identity of the current supervisor who is in charge of 737s, right? And we have the total number of 737s that we have in our fleet as of now, right? And we have the average age of those 737s. So this is an example of this hybrid representation, which is both typification and grouping. Okay? Again, interesting, but you can do that when you actually proceed to the policy level. And then I know that I have to wrap it up. I know that I'm out of time. Let me just finish on this slide. Because what it does here, it actually shows you the so-called compromised definition. So there are two standard examples here that are typically used of showing elements which are individually tracked and those which are tracked as a commodity, basically, in maths. So the proverbial example of the first one is a car. So you keep track of individual cars. So when you want to know what you have in stock, you will actually have descriptions of individual cars. They say by engine number. It's actually by VIN, vehicle identification number. Okay? You will have descriptions of individual cars. And you can have a typification right here and the grouping if you want, if you actually group by type. So which will describe the type of the car. I don't know, Jeep Grand Cherokee, right? So the name, the fuel capacity, and the price, and then you will have a derived attribute, quantity on hand, right? Now try to apply the same logic to a different product. For example, nails, right? With nails, it doesn't really make sense to maintain an operational level entity. Because an operational level entity, we would have to keep track of individual nails, right? Do you really want to keep track of individual nails? Absolutely not. So therefore, we end up with this compromised, actually, definition, where we keep track of this grouping type only, where we maintain all these attributes, but we don't really have individual records. What is interesting when we do this compromised definition is the fact that what used to be a derived attribute here, quantity on hand, is not a derived attribute anymore, right? Because here we could calculate the value by simply adding up the records in this table. If we decide to drop this table, so we don't have any descriptions of individual nails, there is no way to calculate it, so quantity on hand becomes a regular attribute, which is absolutely necessary. It is not a derived attribute anymore. Okay?